Hello class, this is lesson 6-4 about how to factor linear expressions. Now the term factor is really just talking about a number that can be multiplied by another number to get some other number. For instance, if I was going to talk about the number 6, I could say that 2 is a factor of 6 because 2 times 3 gives me 6. The GCF, on the other hand, is the greatest common factor of two or more monomials. So it's kind of like what is the biggest factor, the biggest number that both of those can be divisible by. So here we have an example to find the GCF, or the greatest common factor, of 24xy and 60y. Now there are two methods. Method 1 is to just simply list out all of the factors of each term. So let's go ahead and do that. I'm just going to list the factors of 24 and 60. So 24 could be 1 and 24, or it could be 2 and 12, it could be 3 and 8, it could be 4 and 6, and I think that's about it. 60 could be 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. I believe those are all the factors. And now that I have it written out, I can see what is the greatest number that they have in common, and that would be 12. So the GCF of these two monomials would be 12. And now I need to look at the variables as well. They do not both have an x in common, but they do both have a y. So I'm going to add that on. So the GCF would be 12y. The second method is called prime factorization, and this is where we're going to write out all of the prime factors. So 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3, and then I have the x and I have the y. And then 60y I could write as 2 times 30, but 30 is 2 times 15, and 15 is 3 times 5. And then I also have a y at the end. So now that I've written out all the prime factors, I'm going to circle what they have in common. So they have a 2 in common, and another 2 in common, and a 3 in common, and a y in common. So the GCF, I would multiply all of those. So I have 2 times 2 times 3 times y, which again is 12y. So it's kind of up to you which method you want to use, but I like using the prime factorization, so that's what we're going to practice here. So let's find the GCF of 18a and 20ab. 18 is 2 times 9, and 9 is 3 times 3, and then I have my a. 20 is 2 times 10, and 10 is 2 times 5, and then I have my a and my b. And then I'm going to circle what they have in common, and all that I can find is a 2 and an a. So that means that the GCF is going to just be 2a. All right, let's find the GCF of 42CD and 14C. And I'm going to start by seeing if they're divisible by 2, which it is. So that's 2 times 21, and 21 is 3 times 7. And then I have my C and my D. 14 is 2 times 7, and then I have my C, and that's it. So now I can go ahead and circle what they have in common. They have a 2 and a 7 and a C in common. 2 times 7 is 14, so my GCF is 14C, and I'm done. So now we're going to move on to looking at linear expressions, and we're going to write these in what's called the factored form. And this is when you have a linear expression that is written as a product of its factors. Okay, so we need to figure out what can we take out of both terms And that's what we're going to factor out. And so in the end, you're going to be thinking of this as looking like the distributive property, and we're just going to be working our way backwards to be what it would look like beforehand. So 12a plus 6b, I'm looking at them and they both have a 6 in common, so that would be the GCF. So really, it's kind of like I'm going to be dividing both of these by 6. So 12a divided by 6 is 2a, and 6b divided by 6 is just b. So the final factored form would be 6 parentheses 2a plus b. All right, let's do that with 3x plus 9. Looking at those two terms, I could see that the GCF is going to be 3. So I'm going to factor out a 3. And when I do that, I'm left with x plus 3. And I'm done. All right, our next example is 6mn minus 14m. So the number that they have in common, the greatest, would be just 2. And they also have an m in common. So I'm going to factor out 2m. And when I do that, I'm left with 3n minus 7. And that's it. So 2m times 3n minus 7. All right, our next example is 12x plus 7y. They don't have a number in common, and they also don't have a variable in common. So what we're given is the most simplified form. And so all we would write down is that it cannot be factored, and that's it. So looking at my next example, I could see that they both have a 1/4 in common. So that is going to be my GCF, is 1/4. So I'm going to factor out 1/4. And I'm left with, on the inside, p plus 1, because 1/4 times 1 equals 1/4. And so that is the factored form of that example. And then my final example here is 1/3 t minus 2/3. They each have a 1/3 in common, but they don't have a variable in common. So I'm just going to factor out the 1/3. And when I do that, I am left with t minus 2, because 1/3 times 2 is 2/3. And I'm done. So I hope that this is a lesson that made sense to you, but please let me know if you have any questions when you come into class.